So the main benefit of going for the wireless is what? Mobility. It doesn't matter where you are inside the campus. You are at your cubicle, no worries. You are in conference room, doesn't matter. You are in pantry, doesn't matter. You are any part of you might be standing anywhere inside your campus. As long as you're inside the campus, you will be able to connect it to your network. You can do your work from wherever you want. Right? So earlier days, if you're stuck with someone and you're planning to take somebody's help, you have to call them. Can you please come and check it out? What is that going on? They'll come to you all the way. They have to come to your desk and they have to see the screen, and then they will be helping you out. Same way, if you are helping someone, you have to go to their desk and then you have to support. You cannot carry your desktop all the ways, right? So then we have started giving the laptops are equipped with the wireless. Because of that, the users can move from one place to another place. Nowadays, working from home is also happening. So of course, that can be wired or wireless. That doesn't matter. We have to have internet connection. So the main benefit of going for wireless is what? Mobility. Right? So in that way, we are not restricting the users to sit in one single place. They can be traveling anywhere. Right? So now we have like what we had in your LAN technologies. Like we used to call it as what? LAN, MAN, WAN, like this we used to talk about, right? So same way, even in wireless networks also, we have WPAN, that is that wireless personal area network. Like if you're connecting your Bluetooth, like if you're enabling tethering in your Android, you're enabling the hotspot, right? Basically what is that happening? You are connecting to your mobile phone's internet. Your laptop or your machine is connecting to internet via your mobile phone's internet connection. You understand what I'm saying? So you can also create a personal network. Like if I'm using an iWatch, right, it is connected to my iPhone. I'm also using an AirPod. All of them are forming a small closed network, which I call it as a wireless personal area network. You understand what I'm saying? So we also have something called as what? WPAN, then WLAN. What is that WLAN? We know what is LAN. LAN is a local area network. If that happens in a wireless manner, then we call it as wireless LAN, WLAN. Same way, we also have something called as what? WMAN. What is that MAN? Metropolitan area network. If that is going to be happening via wireless, we call it as what? Wireless MAN or WMAN. You understand? So whatever you had in wired, the same set of things are available in your wireless also. Because of that, we are calling it as WMAN. Okay. Now, see, there are certain things. What is that? With respect to providing connectivity and all. How do you connect the wireless devices together? Like there is something called as what? First thing, I forgot that one, which is called as what? Ad hoc. Ad hoc in the sense what? I have a wireless device, you also have a wireless device, you can connect together and then we can start exchanging it. There is no centralizer device, there is no intermediary device. You and me are connecting together. That's what we call it as ad hoc. Like that you can connect one more device, like that you can connect. Now there is also something called as what? An infrastructure mode. What is that infrastructure mode is? Like a switch. If you have a switch, multiple wired devices can be connected, correct? Multiple wired devices can be connected. Same way, you wanted to have a connectivity through the help of a switch in wireless. Yes, it is possible. We call this as an access point. You understand? There is something called as an access point. Access point will allow multiple wireless clients to get connected to that, but wirelessly, not using the wired mode. We call this mode as what? Infrastructure mode. You have something called as what? An access point, and that access point is going to be providing connectivity to multiple wireless clients. You understand what I'm saying? Is that clear? Right? There is also some more thing called as what? Wi-Fi direct. What is that Wi-Fi direct? For example, if you are planning to connect your mobile phone with your TV, right? So that's called as a wireless direct. You have a printer and you want to connect to the printer directly. We call that as what? Printers, Wi-Fi direct. So using the Wi-Fi direct, you can connect to a specific set of devices. We call them as what? Wi-Fi direct. So infrastructure mode is there, ad hoc mode is there. We also have something called as what? Wi-Fi direct is there. So infrastructure mode is the popular technology in organization because it will allow us to get connected to the wired network also in an enterprise. Let's assume like this. So we have a wired network using a switch. We have the connectivity, and this switch is connected to a router, and you have a server network, and then in turn it is connected to the internet. Let's assume like this. Then multiple wired PCs also connected. Now my point is, this switch can be connected with an access point, right? As an access point, we typically having an identification like this. We keep like this, okay? This is the identification of wireless access point. Okay, so we have an access point, and the access point is going to be connected to the wired switch, and you have the wireless clients connected to the access point. So you have a wireless network, WLAN. This WLAN can be communicating with the wired network also. You understand what I'm saying? So you have a connectivity with the access point, right? Now in this case, your switch is going to be considered as what? A distribution system, because it distributes the traffic between wired as well as the wireless as well. You understand? So the communication can happen from wired to wireless, from wireless to wired, because the router is connected to the wired network, and the router is also providing connectivity to internet as well as to the internal server. People, whomever is connected on the wireless, if they wanted to access the servers, they can. If they wanted to access the internet, yes, they can. You understand what I'm saying? புரியுதா என்ன சொல்றேன்னு சொல்லிட்டு புரியுதா? Okay. Right. Now the point is, if your organization is larger, right? If your organization is larger, you cannot have a single access point, because we have a limitation of the coverage area. What would be the maximum distance an access point could cover? It purely depends on something called as transmit power. Like what? I have something called as transmit power. Can I increase the transmit power? You can, up to the maximum supported by the device. But what is the problem in increasing the transmit power? Because of that, I can have my access point at my home in Tiruvannamalai, and I can access that one from Chennai. Can I do that one? If you have the transmit power enabled, obviously you could do that one. But my point is, if everyone is doing that, then what will happen? The whole world is going to be congested with wireless frequencies. You understand? So now what we want is, there are certain restrictions. According to Indian government, there is an organization called as what? TRAI. TRAI is regulating the maximum transmit power on the access points that can be positioned in India. So whatever the access point or whatever the wireless router that you buy, they have to adhere to TRAI's regulation, Telecommunication Regulatory Authority of India. They have that restriction. So because of that, every access point has a limitation with respect to the total area that can be covered. So if you want more area to be covered, then you have to have more than one access point. Okay, I have an access point 1. I also have an access point number 2. Okay, this is access point number 2. So this can serve, access point 1 can serve set of clients, and access point 2 can support, what is that called? Another set of coverage area, right? So what we normally call this as? We call this as BSA. The coverage area is called as what? BSA. BSA is nothing but basic service area. The area where my wireless coverage is going on, I call it as a basic service area. You understand what I'm saying? Is that clear? Now there is one point, if this wireless signal and this wireless signals are all operating in the same frequency, they can collide with each other. So obviously we have to work in a different frequency of one access point and different frequency of second access point. Then how come they can roam between each other? Like you have the connecting point, right? So because of that, when users are moving from one place to another place, they can seamlessly detach from this access point and attach to the other access point, which we call it as roaming. And the roaming can be done in layer 2 level as well as at layer 3 level. Okay, now there is one point now confusing for me. What is that? If I go and check my wireless networks, available wireless network here, can you see them? I have iPhone, I have HJT Student, I also have Test June. There are so many wireless networks are there. How do I know that which one is mine? If it is wired network, I know to which of the interface I have to connect, to which of the switch, to which of the interface I have to connect, so that I can say I'm connected to that particular wireless, that particular switch. In wireless, it is quite possible in a building, multiple companies can have their own access points. How do we know that this is my access point? So that is where the service set identifiers comes into picture. We call them as what? SSID. Okay. So there are two different things. One is called BSSID. then ESSID. So basic service set identifier, extended service set identifier. Basically, BSSID is nothing but the identification of an access point through the help of a MAC address. You understand? Service set identifier, basic service set identifier. Okay, so basic service set identifier is nothing but identification of the MAC address. A single basic service area is going to be responsible for that particular access point. But you wanted to extend the coverage, right? You wanted to extend the coverage. Then how do I handle it? How do I cover how do I cover a larger area? I'm placing multiple access points. Now what happened? This is also going to be my coverage area, my area only, and this is also going to be my office only. So the signal should be covered on both the sides. It should not be giving a different identification for that. So point number one, BSSID is the MAC address. How do you remember the MAC address? You need a name. That is what I call it as an SSID. SSID is a name which is mapped to a BSSID. Now SSID is mapped to BSSID. If you have two access points, you will have two MAC addresses. Then do I have to create two SSIDs? Then it is not going to be an infrastructure mode at all. See, we need to have the same SSID mapped to this access point and mapped to this access point. Because of that, if I'm going here, then I'll be connecting to this access point using the same SSID. If I'm coming here, then I'll be connecting to this access point using the same SSID. That is the benefit of extending a service set across your campus, so that the user might be standing in any place within your campus. They can be connecting to your wireless network. You understand? So what is it basically we're trying to say is, this SSID associated to an access point is going to be sent as a broadcast, advertised as a broadcast. Because of that, the clients, whomever is standing in that coverage area, they will be able to see that, okay, these are all the SSIDs are available. Which SSID is mine? I can select and then I can connect. Getting my point? So that is what the broadcasting of SSID. But if you don't want it to reveal your company's SSID, you can also hide it. You can hide that one. So that is called as hidden SSID. What is a hidden SSID? The broadcast is not going to be happening. So as a user, you must be aware of what is the name of the SSID. Then you have to configure your wireless PC to connect to that particular SSID. Then you can go for it. You're getting my point, right? Okay. Now there is something. What is it called? Now when I have a larger space, assume that my total coverage is like your DLF, or you think about your college, whichever the college you have studied. What is the size of your college? Is that going to be 1,000 square feet or 2,000 square feet? The overall college? Obviously no. Right? So you will be having so many buildings, you will be having a ground, you will be having a separate office, and multiple buildings for classrooms, right? You will be having an indoor games. I'm not sure, I'm just telling you. The campus is going to be larger in size. Now, how do I provide connectivity for all of them? That's where I'm going to place multiple access points across my campus to provide the coverage in each and every corner of my campus. Now, how do I configure them? I have to go and configure access point 1, I have to configure access point 2, I have to do the configuration of access point 3. Like this, I have to configure it. Now, the problem is, if I have to do roll out a small change, I have to roll out a small change. Because of that, what will happen? I may need to repeat the same work across all of my access points. Assume that I have 300 access points rolled out. If a small change needs to be done on all of this 300, I have to do those change. Only then I'll be in a position to see the changes getting affected on all of the access points in total campus. So this is going to be a tedious job. So what happened now? We are getting into something called a wireless LAN controller. Now, what is this wireless LAN controller will do? It's a centralized administration of your access points. So now all of the access points will be connecting to the wireless LAN controller, right? So the access points will be having an IP address, and using that IP address, the WLC can communicate with it. Now, any changes that you wanted to do as an administrator, you log into the WLC, do the changes, and say that which are all the access points this change needs to be reflected. If you want the changes to be reflected in all of the access points, you can push the configuration to all of them. Now, this point, this wireless access points, right? They called as LWAPs, light-weighted access points, because the system boots up. Every time it boots up, it will get associated to the WLC and requesting for the configurations and firmware, whatever you want. Everything, the decision on the LWAP purely dependent on the WLC. According to the WLC, all these LWAPs are considered as what? Dumb terminals. Okay? All of them are going to be considered as what? Dumb terminals. You understand what I'm saying? So that is one point like this. Okay. Now the same way, you also have another concept. If I have a wired switch, I'm allowed to create VLANs, right? What is that VLAN? What is that VLAN? A logical separation of a switch. Every switch is going to be considered as a LAN. A switch, physical switch, is going to be logically sliced into multiple. Because of that, what could be possible is you can create multiple logical VLANs. The same thing is possible with your wireless also. Even in wireless, you can create multiple VLANs. Now what we have to do is we have to create an SSID, map it to a VLAN 1. Create another SSID, map it to VLAN 2. This is how the segmentation of network could be possible even in your wireless network. Quite possible. You understand what I'm saying? Is that clear? Okay, so that is what we are trying to understand here. So SSIDs can be associated with the VLANs. The switch is going to be connected with the access point is going to be considered as a trunk port. Okay, now WLC is here. We have LWAP and we have a switch. We have a wireless LAN controller connected to the switch, and we can have multiple switches because we may not be having a single switch where all the access points can be terminated. Now I have a switch connected to an AP. Now because I have multiple VLANs, I'm going to be configuring the interfaces as what? This port as a trunk port, right? Whereas this port is going to be considered as an access port. You can create as a trunk port. You can also create them as a access ports. It's quite possible depending on your implementation. How do you want it to do it? Right? So you can create the port as a trunk port, and you can configure the allowed VLANs, and you can configure this port as an access port, and then a CAPWAP tunnel will be established. There is a protocol which is going to be established, which is going to be enabled for communication between your wireless LAN controller and LWAP, and that protocol is called as a CAPWAP protocol. Okay? Anyway, so this is just for your understanding. When you go through it, you will be able to understand them. Okay, so we have a CAPWAP tunnel that is going to be established between your wireless LAN controller and access point, right? Any data traffic coming from the wireless, what is it called? The wireless client, it will come to your access point. From there, the traffic will be tunneled to WLC, and then the WLC is going to be sending the traffic to the respective VLANs, because WLC knows which VLAN or which SSID is mapped to which of the VLAN. That part is very clear. So if you don't want this access point to be managed by the WLC, there is also a possibility that I can remove this from the bounding, then I can make this as an autonomous AP. Autonomous AP is nothing but the AP doesn't rely on the WLAN controller. Any configuration you want, you do it directly on the access point, and you don't need to have a CAPWAP tunnel being established. Okay. Now in this case, what is that going to be happening? If I have an autonomous AP connected to a switch, obviously this is going to be a trunk port, right? Then wireless AP is providing connectivity to multiple wireless clients. And you also have something called as what? A work group bridges. Are questions? Idvariki questions? Okay. We also have something called as what? A work group bridges. Basically, work group bridges are going to be connecting your wired network as well as a wireless network. One side you will be having wired group bridge or work group bridges. On the other side you will be having wired switch. On the other side you will be having access points for the wireless communication. You also have mesh networks. What is that mesh network? Every access point is going to be connecting to every other access point to provide the overall coverage of your organization or the campus. Now when I'm having multiple access point, as I said earlier, it is quite possible that, what is that? Okay, where's my, okay, so there are multiple access points. If they are all operating at the same frequency, actually speaking, there are certain frequencies that you have to be familiar with. The standard for wireless is called as what? 802.11. For WiMAX it is 802.16. Okay, now 802.11, you have 2.4 gigahertz operations, you also have 5 gigahertz operations, right? So in 2.4 gigahertz 802.11, it operates in, okay, let me call this as plain 802.11, operate at the speed of 1 Mbps to 2 Mbps, right? If I go for 802.11a, operation is going to be on 5 gigahertz, the data rate can be 6, 9, 12, maximum of 54 Mbps is what you will get it. If I go for 802.11b, it operates in 2.4 gigahertz, the maximum speed is going to be, the maximum speed will be 11 Mbps. If it is going to be G, the maximum speed is going to be 54 Mbps. If I go for N, 802.11, the maximum speed can be 600 Mbps. The current scenario, which is 802.11 AC, you can go for maximum of 3.5 Gbps of speed. This is the maximum you have. So the current scenario, we are using all of your devices equipped with 802.11 AC. I'm not sure what phone you have. Check it out. What is the technology that you have on your mobile phone? Every check pannalam. How do we check it out? I have it my wireless la. Give me a minute. I'm just checking it out where I can find the interfaces. I'm not able to see that, but you can see them. I don't know why it's not showing it. Unga phone la kaatudha enna idhula irkingante? Unga phone la edha kaatudama? What is that you have அப்படின்ற மாதிரி? 802.11 AC யா? Okay. மேக் அட்ரஸ் மட்டும் காமிக்குது, பட் ஆனால் இருக்கும், எங்கேயோ ஒரு இடத்துல இருக்கும். நான் பார்த்துருக்கேன், என்னோடய ஃபோனில் நான் பார்த்துருக்கேன், பட் ஐம் நாட் ஷுர் எங்கே பார்த்துருக்கேன் அப்படின்ட்டு. என்ன பார்க்குறேன், தான் காட்டுதான்ட்டு. எனக்கு இதுலேயும் காட்டலை, ஆனால் எங்கேயோ பார்த்துருக்கேன் நான். நீங்கள் எங்கேயா பார்த்தீங்கன்னா பாருங்கள், எனக்கு சொல்லுங்கள் என்ன கெப்பாசிட்டி அப்படின்னு சொல்லிட்டு. நம்பர், சிக்னல், எட்ஸெட்ரா, சிஸ்டம், ஐபி அட்ரஸஸ், மேக் அட்ரஸ் காட்டுது. மேக் அட்ரஸ் மட்டும்தான் காட்டுது, வேறு எதையும் காட்ட மாட்டேங்குது எனக்கு. பட் யூ கேன் டூ ஒன் மோர் திங். என்ன அப்படின்னா, யூ கேன், நான் ஸ்க்ரீன் ஷேர் பண்ணியிருக்கிறது தெரியுதா இல்லையா? ஸ்டாப் பண்ணிவிட்டு ஷேர் பண்ணுறது திரும்ப இருக்கு. ஸ்க்ரீன் ஷேர் பண்ணியிருக்கிறது தெரியுதா? ஓகே, ஒரே நிமிஷம். இப்போ இங்கே பார்த்தோன்னா பாருங்கள், இப்போ வந்து ஐஃபோன் 11 ப்ரோ இதுதான் என்னோடது, சரியா? இதில் என்ன இருக்குதுன்னு பார்த்தோம்னாக்கா, ஜிஎஸ்எம் அரேனான்னு ஒன்று இருக்கும் பாருங்கள். மொபைல் பற்றி தெரிஞ்சவங்க தெரியும். போனேன்னா ஃபுல் ஸ்பெசிஃபிகேஷன் எனக்கு காட்டும். மெமரி, சவுண்டு, கம்யூனிகேஷன் பாருங்கள் என்ன காட்டுதா? வைஃபை, ABGN AC and Wi-Fi 6 is also supported. Can you see that? AC அப்படின்னு காட்டுதா? தெரியுதா? அது என்னோட ஃபோன்லேயும் போய் நான் பார்க்க முடியும். ஐ கேன் கோ அண்ட் செக் தட் அவுட், பட் ஐ எம் நாட் ஏபிள் டு ஃபைண்ட் இட். உங்களுக்கு சொல்லுங்கள் என்ன ஃபோன் வச்சுருக்கீங்கன்ட்டு. யாரோ ஒருத்தர் சொல்லுங்கள் ஒரு ஃபோனை. Redmi 5A வா? ஓகே, இதை பார்த்தீங்கன்னா இதுலேயும் பார்க்கலாம். நீங்கள் ஃபார்ம்ஸில் பார்த்தீங்கன்னா இதில் பாருங்கள் ஏசி இல்லை. You have BGN and you also have Wi-Fi direct. நம்ம இப்போ தான் பேசணும் what is Wi-Fi direct. You can directly connect to the devices which supports Wi-Fi direct without any access point or something like that. You don't need to have it. And directly connect, you can directly do the work. But the wireless supported is what? BGN. There is no support of AC. If you have AC, you can get high speed connectivity. 5A is a little bit old model, la? I think right. Okay, fine. So that's what we need to understand. Okay, so there are different types of speeds are available, and each and every standard is going to be talking about a specific SID, and they're also going to be operating at a specific frequency, right? So you have UNNI band, you also have what is it called, medical. There is one more band is there. What is that band? You remember that? What is that band called? ISM band. There is a band called as what? ISM, Industrial, Scientific and Medical band, which is 2.4 gigahertz. And you also have UNI band. UNI band you have in two different options as well. What is that? 2.4 to 2.4835. You also have 5.5 gigahertz as well. So UNI band basically from 5.15 to 5.825. Like 93.5 சொல்கிறீங்க இல்லையா, அதெல்லாம் நேரோ பேண்டு. என்னாச்சு? இல்லை எதுவும் எழுதலை நான். I didn't write anything. Like if you're talking about the frequencies of your FM, 93.8 இல்லை 98.5 ஏதோ ஒன்று இருக்குது பாருங்கள். So every FM channel is going to be identified by a specific frequency, கரெக்டா? 93.5ன்னு வச்சுக்கோங்களேன். So this is a narrow band. You are operating in a single frequency. Whereas in wireless we work as a spread spectrum technology. Multiple spectrum na ஞாபகம் வந்துருமே உடனே. அந்த ஸ்கேம்லாம் ஞாபகம் இருக்கா? Spectrums 2G 4G spectrum or 2G spectrum ஏதோ ஒன்று. So that is what the spectrum is nothing but a range of frequency they are going to be communicating, they are going to be used together for the communication. So we have different frequency ranges. They are all going to be combined together with respect to exchanging the data from point A to point B. So UNI band operates in 5 gigahertz, whereas ISM band which operates in 2.4 gigahertz. GSM 900 and 800 megahertz. நம்ம GSM use பண்றது கிடையாது, but still if I take the 2.4 gigahertz, right? So you have something called as one channel. What is that channel அப்படின்னா? A range of frequency. For example, let's take a case. 2.4 gigahertz ISM is the band where the operational frequency is going to be 2.4 gigahertz. Okay, so starting from 2.402 gigahertz ending with 2.483 gigahertz. This is the range of frequency available in ISM band 2.4 gigahertz, right? In this, for every channel, the width of the channel is 22 megahertz. That means 1 megahertz, 2 megahertz, 3 megahertz, like this 22 megahertz put together, we call it as a channel or channel width. That's what we call it as. A channel width is going to be 22 megahertz. So we have channel 1, we have channel 2, we have channel 3, like that we have multiple channels, right? So every channel is going to be of 22 megahertz. So how many channels we have? 14 channels we have. How come we can get 14 channels? Because one channel is 22 megahertz multiplied by 14, it is not going to be like what? 14, 220 plus 88, almost like 308 megahertz supposed to be there. Whereas here 402 to 483, that is what we have it, correct? So 402 to 483, approximately only 81 megahertz is there. How come you will be able to have 14 channels? That means the channels are going to be overlapping with one another. What I say that the first channel starts with the 2.402. The second channel's the initial bandwidth initial frequency is going to be 5 megahertz away. So this is going to be what? 2407, then 2412, then 24, like this will go. Give me a minute, I will show you the spread spectrum so that you will be able to understand it. Where is that? 2.4 gigahertz spread. This is the one. So this is how, can you see them? So 2.402 to 2.483. So you can see that you have 22 megahertz, and you can see that for every frequency, for every channel, you have 22 megahertz of length, and you can see that there are multiple channels, and the first channel is overlapping with second, third, fourth and fifth, but sixth channel is not overlapping with first channel. Same way, 11th channel is not overlapping with any other channels. So if I'm going to be using channel 1, channel 6 and channel 11 within my organization, and it is not going to be overlapping with each other, if there is no overlapping, there is no interference also. So what I have to do is, according to my requirement, I can say that there are multiple access points I'm going to be placing it, right? Access point number 1 can operate in one frequency, or access point number 2 can operate in another frequency, access point number 3 can operate in different frequency altogether. So the point is, if they're all operating in the same frequency like channel number 1, they are also going to be interfering with each other. So what I try to do is, one access point is operating in frequency channel number 1, access point number 2 can operate in channel number 6. Can I use channel number 2? If I use channel number 2, already interferes with channel number 1. I don't want to use this. So that's why I'm choosing a channel which is called as a non-overlapping channel. So 1, 6, 11 are going to be non-overlapping channels. So I can mix and match on each and every access point, so that one channel is not going to be interfering with the other frequency of other access point. புரியுதா என்ன சொல்றேன்ட்டு? You understand what I'm saying? Right. I think இது போறோம்னு நினைக்கிறேன். இன்னைக்கு நம்ம இன்னும் இருக்கு, வயர்லெஸ்ல பார்க்க வேண்டியது இருக்கு. We will see them by, எனக்கு போரும் தான் நானும் ஃபீல் பண்ணுறேன். கொஞ்சம் ஓவர்லோடடாக தான் இருக்குல்ல.